all, in this video we will talk about line regulation in regulators. For explaining about line regulation, we have considered a GNR based voltage regulator, and we are going to talk about line regulation. So line regulation basically talks about the variation of output voltage with variation of input voltage. What do we mean by it? Basically, the regulator in electronics means it has to provide a constant voltage to a load. Okay, that is possible with GNR regulator because GNR has a specific breakdown beyond which even though you apply voltage, the voltage, more voltage at the input of tuner, the voltage remains clamped. So we can see this from this particular graph. So as the breakdown voltage has been reached, so the GNR conducts more current, but voltage remains the constant. So the GNR current will be between Z max and Z min. So that's how the GNR operates. And GNR based regulator regulates. So this can be known from the VA characteristics of GNR diode. Now, why do we need line regulation? Okay, why do we need to consider? So line regulation need to be considered because when we change the input voltage, irrespective of change in input voltage, we always need to see regulated output to the load. That is why we use regulators, right? So change in output voltage V out, okay, to, that means the ratio change in input voltage. So delta V out by delta V in is nothing but line regulation. Very, very important. Okay. So when you see this, how should be the line regulation? So line regulation should be as low as possible, right? Even though you vary V in over a wide range, okay, but that means the difference between V max in, okay, minus V minimum in. Okay. So that means input voltage, whatever the maximum we give minus V min, that is at the denominator, and the variation of output voltage V out max, okay, or V max out, whatever, minus V out min. So this is how we calculate the line regulation. So this variation should be as minimal as possible with any high variation of the input voltage. That means the denominator variation would be higher and numerator variation would be lesser. So when numerator variation is lesser, that means the line regulation percentage should be as low as possible so that we can treat that it is a proper regulator to be used. Now we will look at one of the data sheet to see how the linear regulation value is. So we are looking at LM317, which is a commonly used adjustable regulator. This is not a GNR based regulator, but we are just considering a regulator linear regulation to check out how low or whether the value should be low or high. Okay, when we read this, okay, the device features a typical line regulation of 0.01%. Okay, we will talk about load regulation later. That means the delta out by delta V in is 0.01%. That means very, very low. Okay, so what would be the maximum and minimum value of this? Let us go through the data sheet to see the line regulation value. Okay, so if we go through the specifications, the electrical specifications, you can see here VA minus V naught is 3 to 40 volts, and based on temperature we see that the line regulation is around 0.04% per volt, which is very clear. So for volt per volt, how much is per volt input variation? How much is the output variation? That's how we generally calculate. Okay, so you can see a very less value. That means changes in input voltage will not affect the output voltage, and output voltage almost remains constant. So that's how we have to read line regulation. So when you are selecting a regulator, selecting verifying the linear regulation is very important. If you have a very strict tolerance at the output voltage side and a high variation of input voltage, you need to consider this line regulation to see how it is varying. So some of the data sheets, in fact, most of the data sheets do have line regulation graph. You can see here V in versus V out. So as we change V in, you can see there is a variation of output voltage, and this output voltage variation is again depending on or the amount of input output voltage variation is depending on at what temperature you are operating. So if example, if you are operating at room temperature, you can see the input voltage variation, the output voltage variation for a change in input voltage is lesser. That means the linear regulation is good. But when we go to 125 degrees, you can see the output voltage has varied a lot over a range. So we can say the line regulation is depending on temperature because of the thermal characteristic of the components that are a part of the regulator. So if we go back to the specifications, here also we can clearly see at room temperature, the maximum line regulation is 0.04% per volt, whereas when we go from till 125 degrees, the line regulation value has increased. Very important parameter to understand. Um, and again, if you see this graph, you can also see it was given at minus 40 degrees centigrade. So when you are selecting operating temperature also matters, right? So when you are intended to use for specific temperatures, we have to look at the graphs to understand how the linear regulation is happening in the regulator before taking a decision on the regulator. So generally, most of the people do go ahead with the uh, input voltage range, if the output current, and mostly select this. But if your output tolerance cannot be high, then you have to look into this line regulation for sure and decide on using the regulator that you are evaluating. Very important parameter, right?